tutorial, I'm going to be taking you through the comparative chemistry of the aliphatic hydrocarbon, part 2. You know, in the previous video, part 1, I discussed about some features, and here in this video, I'm going to be discussing about the features you are seeing on the board. And as you can see, those features include the bond strength, the bond angle, the reactivity, the reactions, and the hybridization. Alright, we have already established that the difference between alkenes and alkane is that alkane is 2 hydrogen lesser than alkanes, and the same pattern goes for alkynes. Now in this video, we are going to start with the first feature, bond strength. In terms of bond strength, what do you think will be stronger between alkenes, alkane, and alkynes? Since alkynes have triple bonds, and the triple bond is their functional group, and there's this saying that said 3 chord is better than a 2 chord. A 2 chord is better than 1 chord. That means when it comes to strength, this is the strongest, and this one will be stronger, while alkane will be strong. And when it comes to bond angle, in terms of bond angle, the alkanes will be more closer to each other since there are enough hydrogen. So therefore, the bond angle of alkane will be 109.5 degrees. And when it comes to the bond angle of alkanes, since there is at least subtraction of 2 hydrogen, there will be a gap that was created, there will be a distance that was created, and therefore there's an increase in distance, which is 120 degrees apart. And when it comes to alkynes, since there's lesser number of hydrogen again, there's going to be a more separation between the atoms, giving it a more larger angle. So this is the bond angle, 109.5 degree, 120 degree, and 180 degree respectively. Then reactivity. When it comes to reactivity, alkene is the most reactive. This one is more reactive, and this one is least reactive. This is the one of the anomaly that existed. Although some scientists argue that alkyne is more reactive than alkene, but to me, I will say alkene gives moderacy. Alkane is like too low of everything is bad, and for alkyne it's as if too much of everything is bad. Alkane has single bond, alkyne has triple bond. So this one is too low, this one is too much. But for alkane, there is moderacy. This is telling us the importance of moderacy in life. Too much of everything is bad, too low of everything is bad. Hyper and hypo conditions are bad. But when we come to alkenes, alkane are just 2 bonds. That means reactions is possible from both up and down and from both left and right. This is what makes alkenes stood out. So in terms of reactivity, alkenes are most reactive compared to alkane and alkyne. Now when it comes to reaction, one reaction is specifically unique to alkanes. Alkanes does not undergo addition reaction. Why? They are called saturated organic compounds. If you are already saturated, that means you have all sufficiency. It means all you need has been granted. So you don't need anybody or anyone to add to you. The only thing you can try to consider is substitution. Okay, do you have something better than what I already have? Like the halogens, like the OH. Okay, let me give out what I have that is not that I noticed that what you give to me, what you carry is more better than what I have. So let's exchange. So the only reaction that alkanes undergo is substitution reaction. And when it comes to alkanes undergo both substitution and addition. And when it comes to alkynes, they also undergo substitution and addition, since they are unsaturated. If you are unsaturated, it means you don't have enough. So if anybody offer you anything, you are going to gladly accept. But note, alkanes does not undergo addition reaction. Another reaction that they undergo that is unique to them is chlorination reaction. And even this chlorination reaction or halogenation, let's call it halogenation, it can be all other halogens like fluorine, iodo, or bromo. So let's call it halogenation. Alright? Let's call it halogenation reaction. So they also undergo halogenation reaction in the presence of UV light, ultraviolet light. So they will displace, for example, methane, CH4, we displace all with HCl, we displace all its hydrogen. With Cl4, with chlorine, is an example of halogen. We displace all its 4 hydrogen to give us tetrachloromethane. So that reaction is unique. But note, this reaction cannot happen unless in the presence of light. When it comes to hybridization of alkane is sp3, alkene is sp2 and alkyne is sp. You will notice that the carbon, which is the foundation of all of organic chemistry, has 4 unpaired electrons, which give it the ability to bond on every side, 4 bonds. So the highest person that can have the highest hybridization, we have 1s and 2p. If you check the atomos configuration of carbon, you are going to see that it is 1s2, 2s2, 2p2. You notice that if one of these 2s electrons in the excited state will jump to this state, therefore the configuration at the excited state will be 1s2, 2s1 and 2p3. Therefore there is 1s and 3p, 2p3. So the highest person, since alkane is the first organic compound, is going to have the maximum. Then as you are going down, since you are reducing the number of hydrogen, then the hybridization will be decreasing by 1 degree. sp3, sp2 and sp. May the Lord give you understanding. You will not fail, you will not fall, you will not falter. Please share this video, subscribe and stay tuned for more impactful videos. Thank you very much.